So if we take a look at the warm-up, like I said, this is kind of, you'll see similar problems to this on the Chapter 5 test that's coming up this week. Okay, Wednesday, Thursday is your Chapter 5 test. And to give you just an idea of what you're going to see, okay, algebraic connections, you will see a factoring type problem. Okay, so that's one thing, that's why it's on there. You'll see some other algebra, pretty straightforward algebra type problems as well. Geometric connections. You're going to see a similarity question on there. We're still working on similarity. It's not been bad, but it's not quite to where we want it yet in terms of making sure you're understanding the idea of similarity and solving for missing parts of similar triangles. So you'll see something like that. You will also then see some of the older trigonometry from the beginning of the chapter that we'd already tested on last semester. Okay, so some of the right triangle trig, kind of like this, an application problem of right triangle trigonometry, things along those lines. Okay, and then the geometric reasoning standard, the new stuff, is basically what we've talked about since your last test, which for the most part is three things. Number one are the shortcuts, okay, 30, 60, 90, 45, 45, 90, Pythagorean triples, things along those lines. Which, remember, you don't necessarily have to do. You could go through and still do those with sine, cosine, tangent, Pythagorean theorem, excuse me. And then law of sines and law of cosines. Okay? So that's pretty much what the majority of your test is going to be, probably more than half will be trigonometry related. Okay, so the current chapter. But if we take a look, number one, I told you to be careful about drawing the picture, because if the picture is wrong, obviously then everything after that's going to be. So if we take a look, Mary decided to find the height of the Empire State Building. She walked 1 mile away, or 5,280 feet from the tower, and found that she had to look up at a 15.5 degree angle in order to see the top of the Empire State Building. Assuming that Manhattan is flat, and if Mary's eyes are 5 feet above the ground, how tall is the Empire State Building? So here's kind of the general picture of what's going on here. We go through, let's say that this is the Empire, the distance that she walked, okay? So let's call that the 5,280 feet. Then let's say that Mary's sitting right here. There you go, there's Mary, she's standing at that spot, okay? Empire State Building is over here. Sorry. By the way, why did they tell you in the problem, assuming Manhattan is flat? What does that have to do with anything? Yeah, they're trying to say, if the Empire State Building is vertical and the ground is flat, that's a 90 degree angle. Okay, that's why that's in there. Then it says that she had to look up at a 15.5 degree angle. So we've done something like this before. If she's looking straight ahead, there's my 90 degree angle, versus now she looks up at the top of the Empire State Building, that angle that we just created is your 15.5 degree angle. Okay, that's your 15.5 degrees. So now, and then same thing here, 5280, we can slide that up, whether it's from her eyes or from her feet. She's still 5,280 feet away. And it tells you that her eyes are 5 feet above the ground. So that is 5 feet, which means we could slide that over. That means from here to here is also 5 feet. And what we're looking for is that piece right there. So bigger picture here for a second. If we're going to find the total height of the Empire State Building, which is represented by this line, one, we got to find x first, and then two, we got to recognize that that triangle is 5 feet off the ground. It's from our eye level up. So we got to add that 5 feet back on at the end. Okay? So this right here is the triangle that I'm really focused on, which happens to be a right triangle, which means, what could I set up in this problem? What could I do? Set up something to solve for x. What do you think? Yeah, Connor? Okay, yeah, we could take a look. It's a right triangle, 15.5 degrees. X is the leg opposite that angle. 5280 is the leg adjacent. We're working with the two legs. So we could set up a tangent problem, okay? Let me set that up and then we'll discuss something real quick. So tangent of our angle, 15.5 degrees, over 1, equal to your tangent ratio, opposite leg to adjacent leg. So in this case, x over 5,280. So there's our setup. Now let me ask you a question, because this came up in the other class that I was talking to. Could I use law of sines here? Or law of cosines even? I could. It'll work, okay? Just most of the time what we've been talking about is if it's a right triangle, you've already got tools to do it. But you theoretically could solve this with law of sines, okay? And go through and figure it out. That would work, I'm telling you that right now, okay? But because we've got some tools to deal with right triangles in particular, that's why I wanted to focus on this, okay? So now that we've got a proportion, now we can cross multiply. X times 1 is x equal to 5,280 times the tangent of 15.5. Normally I'd say solve for x. It's already solved for in this case, so now we go straight to the calculator. And x equals approximately what? It's going to be less than 5,280. I want to say it's 4,000 something. Somebody get it for me? What's the value of x in this triangle? Ella, did you get it? What did you get?
I got 1,467.
1,000 for, for your final answer or for x?
Oh, for my final answer.
Okay, so 64.27.
Yeah.
All right. So if you solve this, you end up with 1,464.27. But then to finish off the problem, don't forget that triangle is 5 feet off the ground. You got to add that 5 to get the entire height of the Empire State Building in this case. So if we add 5 to it, my final answer then is 1,469.227. 0.27 feet. So there's a way that you can use right triangle trigonometry in this case in order to figure out, this is that indirect measurement again we've talked about a few different times throughout the class. And like I said, you could do law of sines on this. You would get the same answer. It does work out. It just kind of naturally lends itself to a tangent problem. All right, let's take a look at problem number 2. I told you you will have a factoring problem on the test. There was one on the last test. There'll be another one on this one, just to make sure you're still understanding this. I told you factoring is really important as we move forward into Algebra 2, into CCRM, into pre-calculus. There's factoring at every level, basically, going forward now. So that's why we're spending the time right now. So if we factor this, let me go through and put the 2 sets of factors down. And again, remember, it's basically 3 steps. Step number 1, factors of your first term. Well, that's x times x. Those are the only things that multiply to give you x squared. Then we go to the other end, our constant term. Factors of 24. Now, we've got quite a few factors of 24. We've got 1 and 24, we've got 2 and 12, we've got 3 and 8, we've got 4 and 6. Okay? And so the question then becomes, we're trying to get this middle term. Okay? That's really what we're trying to get. So therefore, what are the factors going to be? Which set of all those factors does it have to be? What is it? Somebody said it. Yeah, it's got to be the 8 and 3. Okay, and here's the question. From those 2, I need to multiply to get a negative 24. So I know the signs, one's got to be positive, one's negative. Yeah, because I need a positive 5x out of that, that means the 8's got to be positive and the 3's got to be negative. So when I multiply those, I get a negative 24. And when I add those, I get a positive 5. Okay? So it is factored. It is not done, though. Again, if you stop right there on the test, you're at half credit right now. Okay, you factored it correctly, but you didn't finish the problem and solve it. Which means now, remember the zero product property. If I set each of these factors equal to 0 and solve for x, this one I will get x equal to negative 8. There's my first x-intercept, if I were to graph this. And this one I would end up with x equals 3. There's my second x-intercept. So if you were to graph this parabola, there's the 2 spots on the x-axis that they would cross. 2 x-intercepts. And like I said, you'll see one like this on the test as well. Okay? All right, last one. And here's a kind of a new part. We had an algebraic connections problem, the factoring one. We had a geometric connections one. That was problem number 1, the application. And now we've got some new stuff. This is either a law of sines or a law of cosines problem. So this is one of your geometric reasoning type problems. How do I solve this? What do you think? Is this law of sines or law of cosines? What do we do on this one? Yeah, Tara, what'd you do? Okay, how'd you know it was law of sines versus law of cosines? Yeah. So number one, you know you can eliminate all the right triangle stuff because you've got a 100-degree angle. So Pythagorean theorem's out, all the shortcuts are out, those all relate to 90-degree angles. Sine, cosine, tangent, all that stuff is gone. The only thing you're left with is law of sines or law of cosines. And remember, then it comes down to what you're given in the what given information is in the picture. This is angle side angle, which is what makes it a law of sines problem. Okay, so if we set this up, remember it's the sine of an angle over the side opposite. So I'm going to take the combination of 50 and x here, sine of 50 over x, and that should then equal another combination of angle to opposite side. Okay, but if you take a look, I've got a side length here, but no opposite angle. I've got an angle, but no opposite side. How do I fix this problem? Yeah, I can very easily find the missing angle, and then I've got a combination of angle and opposite side. So far, you've got 150 degrees in this triangle. That means there's 30 degrees left over here for that angle. And now I can set up the second part of my law of sines. The sine of 30 over the side opposite, which in this case is 20. And you are right back. There's the setup of law sines. Now you're right back to just solving a proportion again. We cross multiply. I get x times the sine of 30 equal to 20 times the sine of 50. And just like you've done pretty much all chapter, I got to get x by itself, which means I need to divide out that sine of 30. I need to get that out of there. And therefore, now we type that into the calculator. And what'd you get on this one? What does x equal approximately? Adele, what'd you get? 30.64? Okay. 30.64 approximately. Let's see if that makes sense according to the picture. If we come back up, notice 20 is opposite the smallest angle. 50 is a little bit bigger angle, therefore the side length should be a little bit bigger. Sure enough, it makes some sense. Okay? Makes sense that it's definitely bigger than 20, so we're good there. Again, you will have a law of sines problem on your test. Okay? So you got to make sure you know how to do both law of sines and law of cosines. You'll see at least one of each of those on the test. Okay? Any questions on this at all? All right, what I'd like you to do next then is, last week, Wednesday, I guess was the last time I saw you, I gave you the 5-3-5 practice to learn and the closure problems. Why don't you take out the 5-3-5 practice to learn, and we're going to see if there's any questions on that. Anybody else need that? So just a reminder, as we're going into the chapter test here, that means that's the final deadline for assignments, okay? So anything that you've been given this semester, the last 2.5 weeks, deadline is basically tomorrow, because as you come in and take the test, you gotta have the assignments done. At that point, I put grades in the grade book and I don't accept anything after the fact, okay? Because again, remember the point of the assignments is to practice to hopefully get you ready for the test. Okay, so it doesn't make a lot of sense to get ready after you've taken it. So 5-3-5 practice to learn is one of the assignments that's out there. I also gave you a Delta Math assignment, G17, last week. Those both need to be done by the end of, like I said, basically by tomorrow at midnight, pretty much is kind of the deadline. Okay, so just a quick heads up on that. On this assignment, just a couple of things, and we'll go over any questions that you may want to go over. One of the quick things I want to just give you a heads up as we work our way through this. On problem 126, you were asked to solve for missing side lengths and angles. Here's a side angle side. This is a law of cosines problem to start off, okay? To start off with. For example, if I would call that side x, I can start off by just doing law of cosines very quickly to solve for x, okay? Then you could now you could define one of the angles either using the law of cosines or law of sines. I would use the law of cosines because it's usually more accurate, okay? So just a heads up on that one. Otherwise, I want to kind of open this up. Does anybody have any specific questions that you want to go over from this assignment? Yeah, Jared, what do you got? Sure. So if you take a look at, let's see, 134, maybe. There we go. All right, so if we take a look at 134, this is kind of a combination problem here, okay? Because if you notice in part A, it asks you to find the length of PR, which is this length right here. Okay, so I'm going to call that X. And the first focus that I have is if you take a look at which triangle am I going to work with, well, if I look at the left-hand side, I don't have any side lengths to work with. It's just angles, so that's not going to work out real well, okay? But over here on the right-hand side, if I start off by looking at that triangle, what would I use to solve for X? Law of sines or law of cosines? If that was the only triangle in the picture, yeah, it's a law of cosines problem. Side, angle, side. Okay? Therefore, this is a law of cosines problem to solve for X. So if we do that, remember, key part to using the law of cosines correctly. The beginning and the end of the formula are a side and angle, opposite angle combination again. So if that's the angle I'm going to use, that's the side I need to start the formula with. Okay? So, x squared equal to, B and C in the formula are the two sides. So 7 squared plus 8 squared minus 2 times 7 times 8 times the cosine of, if x is what starts the formula, the angle opposite is what needs to end the formula. This one, in this case, 70 degrees. And if you remember, I told you the nice part about sides with law of cosines, you can type that whole thing into the calculator. That'll give you x squared, and then take the square root from there. Okay? So that should be, hopefully, x should be, part A here should be a quick one, hopefully. Setting it up right is the hardest part. If you do it correctly, what do you get for x out of curiosity? 8.64. Is that what you got? Okay. So approximately 8.64. It looks like it's probably right based on the other side lengths. So there's part A right there. Okay? There's part A. That is the length of PR in the diagram. Now it asks you to find the perimeter of the quadrilateral. Okay? But so therefore, you've got 8, you've got 7. Now you got to find the other two side lengths in order to get the perimeter. But what kind of triangle is this one? What kind of triangle? The triangle PSR. Yeah, Don? Yeah. You got two congruent angles, so I know that those two sides are equal to each other. Okay? So you have multiple options on this one to solve. One, let's say I call this y, okay, which also would mean that that is also y then. Now that you know that this side length right here is approximately 8.64, you could use law of sines if you wanted to now solve for y. Or, theoretically, you could cut this triangle down the middle and just focus on the right triangle and find y that way. Okay? So you can either set up a law of sines problem or cut this right down the middle and just focus on one of the right triangles, which would then cut that 8.64 in half. Personally, I would do a law of sines problem. Okay? So if we do that, let's go part B here. Same thing as what we were doing in the warm-up. Sine of one angle over the side opposite. So, since I know the 8.64, I'm going to start with sine of 110 over 8.64. And then that equals another combination of the sine of an angle over the side opposite. Well, regardless, you got sine of 35 over y. And now we are right back to what we were doing in the warm-up. Cross multiply, solve for y. Once you know y, then you can find the perimeter. So starts off with a law of cosines, and then from there goes into a law of sines type of problem. How are we doing? Does that make some sense, hopefully? Get the idea? Gives you some good practice at both law of sines and law of cosines, all in one problem. Any other questions that you want to go over? Do we need to go over 135 at all? Doing okay on that one? Yeah, Connor?
133.
Okay, let's take a look back at 133. So if you take a look at problem 133, basically we're trying to find the angle measures. So this is a trapezoid as the whole shape. And if you notice, you've got a whole bunch of parallel lines in this picture. Okay? Top and bottom are parallel. AB is parallel to CE. DE is parallel to CD. So you've got a lot of parallel lines, which right away, what should you be thinking of if you've got parallel lines? Should always lead you to this idea. Angle relationships. Alternate interior, corresponding same side interior. Those are your parallel line angle relationships. Without parallel lines, you don't have any of those. So if we take a look, as we work our way through this, let's see here. Well, where do we start? What do you want to do? Obviously, we've got the 40 and the 60. Where do I go from here? What's the first thing I can come up with? What do you think? Dylan, what do you got? Okay. Because these lines are parallel, I can take that 40, it's a corresponding angle, I can slide it. That means this angle has to be 40. And now we've kind of started the process in this case. Yep, Tara? Yep. Now you can use your triangle sum here to find the third angle. So if that's 40 and 60, that's 100, which means that angle's got to be 80. And if we keep going, now we have a highlighted just so you can see it. Got the letter Z right there, which means those are alternate interior angles. So if that's 40, that means this one up here has to be 40. What else? Should be able to find all of these. What else do we have? Now what do you got? Why? Okay, yeah, we can get there. So if you take a look, I'm going to do the exact opposite of what we did here. So I took the 40 and slid it that way, corresponding angles. I can do the same thing with the 60 because those lines are parallel. So if that's 60, that means over here, that means that's 60. These three angles then add up to a nice straight line, 180 degrees, which means if those two are 100, this one is 80. Those two are 120, which means this one's 60. And if that's 40 and 60, that means this one's 80. So it basically comes down to alternate interior corresponding to triangle sum for the most part. Those three angle relationships just repeated over and over and over again. Okay? And then there's part B is starting to set up, actually something that's coming in chapter 7. Chapter 7 is talking about quadrilateral properties. Well, a trapezoid is a type of quadrilateral, and what they're really asking you is what do the four angles add up to? And when they talk about these different angles, what they're referring to, here's angle A. When they say angle ABC, they're talking about that whole angle right there. When they say angle BCD, they're talking about that whole angle, and then angle D. They're basically saying if I took all the inside stuff out, what are the four angles of this quadrilateral actually add up to? Okay. And now that you've got all the numbers, you can take a look. Okay? All right. So I'm going to leave that alone unless somebody has any other questions. Otherwise, I'm going to kind of leave the assignment. So this is one of the things you want to try to get this in. I don't remember if I put it due today or I put it due tomorrow or when I put it due exactly, but it's due basically this week before you take the test, okay? So here's what I want you to do next. Go back to your warm-up and flip that over. And go back to that warm-up sheet and flip that over. There's one new thing that we're going to introduce today. And we're introducing it moving forward, not to be on the test. Okay, this will not be on the test a couple days from now. This is just to move forward into future chapters, and it probably will be on the next test. We've already talked about that. All right, so if we take a look at this one, if you take a look, we're still factoring, but now here's the difference. The value in front of the x squared, the a value, is no longer 1. It's not just a 1x squared, like you did on the front side of the warm-up. Now we've got a 6x squared, or a 2x squared, or a 3x squared. And so we want to take a look at it. Makes the factoring a little bit more difficult, but the process is still pretty much the same. Okay? So we're going to take a look at that. Solving for x. We'll do problems 1 and 2 together. Oh, and by the way, you can cross off problem number 10, because it is a 100% repeat on accident of problem number 4. They're the same problem. So number 10 you can cross off. But let's take a look. Let's do problem number 1 here together. We're going to start the exact same way that we always do. Put our 2 factors down. And it's pretty much the same 3 steps. Step number 1, factors of the first term. But now it's not x and x, because that gives me x squared. In this case, it'll be 2x and x. That'll give me 2x squared. Same second step. Now we come to the other end of the formula. And we take a look at the factors of the last term. The nice part about that, there is only one set of factors. It's got to be 3 and 1. We just got to figure out what goes where. So let's say I start with, exactly the way I said it, let's say I start with 3 and 1. Now, here's your third step, and here's why I taught it this way even when you didn't necessarily need to. You got to check the inside and the outside in order to get this middle term. We're still looking for that middle term. Check the inside and the outside. So here's the idea. If I multiply those 2 together, I get 3x. If I multiply these 2 together, I get 2x. And can I get that negative? Yes, I can, but you got to be careful. Because remember, they have to multiply to a negative 3. Which means these 2 factors, I know that they have to have opposite signs. One's got to be positive, one's got to be negative. So if these have some sort of opposite signs, is there any way to get that negative 5x? Which means we did something wrong. It's not quite right, so we're going to fix it. Okay? So here's the fix. Instead of 3 and 1, let's just flip-flop them and make it 1 and 3. And let's check again. Okay? We're still using the same factors, but now we're just going to double check. So 1 times x gives me 1x. Outside will give me 6x. I know the signs have to be different. Can I get a negative 5x out of that with different signs? If the 6 is negative and the 1 is positive. Which means in order to get that positive 1x, I got to have a plus sign there. And in order to get that negative 6x, I need a minus sign there. Okay? So the factoring's a little bit, it's still the basic same process, but it's really important that you check the inside and the outside to get that middle term. So now I'm going to get rid of this. This is kind of the work that got me to factoring. And remember, that's step number 1. It's factored. Now I need to solve. Zero product property. The nice part is the second factor. Hopefully you can just see that if x equals 3, that factor will equal 0. 3 minus 3 is nothing. Okay? The second one, you may not be able to see it as easily. So just take your factor, 2x plus 1, and set it equal to 0. And then we solve. Subtract the 1 over. 2x equals negative 1. Divide by 2. X equals negative 1/2. It's not the nicest answer, but it's not bad either. It's not too bad. There are your 2x intercepts for this parabola. They cross the x-axis at 3 and negative 1/2. Biggest thing I want to tell you is that it's pretty much the exact same process that we've been working on. It's just a little bit more complicated because of the number in front. Let's do one more together. Let's take a look at number 2. And then I'm going to kind of turn you loose after that. So, same starting point, factors of our first term. In this case, though, now I've got either 1 and 6 or 2 and 3. What I will tell you, general rule that I'm going to give you, and there's not any like specific math behind this, I'm going to tell you to always start with the two factors that are closer together. The only reason I'm telling you that is because based on 20 years of teaching math, it just seems to work more often. Okay? That's what I've noticed of problems that you go through and you do. It just happens to work more often than not. Okay? So I'm going to start with the 2x and the 3x. Factors of the last term. I've either got 1 and 10 or 2 and 5. Again, for that same reasoning, I'm going to start with the 2 and the 5. And I need to check inside and outside to see if I can get a positive 11x. Noticing again, I'm going to need opposite signs here because I got a negative 10 at the end. So if we check inside, 6x. Outside, we get 10x. Any way I can get 11x out of that? Nope, that's not going to work. Okay, so same thing again. Flip-flop the factors and see if we can get the right combination. So instead of 2 and 5, let's say I try 5 and 2. Now, inside I get 15x. Outside I get 4x. Now can I get 11x out of that? With opposite signs. Positive 15, negative 4x will get you that. Which means I need a plus sign there and a minus sign there. And the nice part about this, the more you do it, the easier it gets. You just start going through the routine and you don't have to necessarily draw all this stuff. You can just start looking and being like, okay, I got inside and outside. Can I get that? Nope. Okay, let me try this. And you can start to visualize rather than actually have to do the math. All right, so there are my factors. Both of these are a little bit more difficult to just take a look at. So let's set them equal to 0. 2x plus 5 equal to 0. 3x minus 2 equals 0. Zero product property. And now we solve. 2x equals negative 5. If I subtract that over, divide both sides by 2, and I get x equals negative 5 halves, negative 2.5. There's your first x-intercept. And then add the 2 over. 3x equals 2. Divide both sides by 3. X equals 2/3. Your second x-intercept. So neither one turned out to be a whole number, but that's okay. It happens. Like I said, these type of factoring problems we're introducing today, not because they're going to be on the test, because they won't be, but they will. We're going to deal with them a little bit more often. Matter of fact, if you look at the sideboard, see the Delta Math assignment over there for Friday, G18. That's your one assignment after the test. It's factoring problems like this. Okay, that's the only thing coming out of the test that you got to take care of between now and next week Monday. All right, you don't have a ton of time left, but you do have about 10 minutes. So here's what I want you to take a look at. So what should you be working on? Here are the options at this point. Option number 1, any old assignments. You still have law of sines worksheet, law of cosines worksheet, the right triangle trig worksheet that was like day 1. Okay, that was 2 weeks ago or 3 weeks ago today. Any old assignments. Final deadline is coming up here in 2 days. Delta Math assignment. Last week's Delta Math is due by, like I said, by the time you take the test. Okay, so that's coming up. The 535, we went over a couple of questions from the practice to learn. That is due. Okay. In your 535 packet, remember I gave you not only the first page was the worksheet for 535, but then the rest of it are the closure problems. These are all review problems that'll help you get ready, take you back through right triangle trig. All of these problems are in there. So you could be working on those closure problems, or your final option is you could go through and do some of the factoring practice we just did and kind of finish the back of that worksheet. I'm not going to collect that. It's just practice that you're working on for now. Okay? Other than that, I'm going to get out of your way and kind of check in with you one-on-one and see where you're at, and we'll go from there. Okay? So you should be working on something up here on the board, one of these, wherever you're at as an individual. All right, let's go to work.